human heart is like a magnificent machine. It pumps about 7,500 liters of blood through the entire body each day. The average heart beats 115,000 times each day, or roughly 3 billion times over a 72-year lifespan. It works through electromechanical stimulation. That is, electrical impulses trigger the heart muscle to contract. A heartbeat, known as a cardiac cycle, begins with an electrical impulse in the upper right side of the heart, or atrium. This leads to a contraction, which creates pressure, opening a valve, and allowing the lower heart or ventricles to fill with blood. The signal continues through specialized cardiac cells to the lower heart, triggering another contraction. The signal is then divided in two. The signal that goes to the right side leads to blood pumping from the right ventricle through the pulmonary artery to the lungs, which oxygenate the blood. At the same time, the signal to the left side of the heart, or left ventricle, triggers the pumping of oxygen-enriched blood out to the body through the aorta. A single heartbeat or cardiac cycle typically takes less than a second. The timing associated with opening and closing heart valves are important cardiac timing events, which are critical measurements of a person's health and heart performance. To assess the heart, we have traditionally relied on an electrocardiogram, or ECG, and the echocardiogram. The waveform displayed by an electrocardiogram is the iconic representation of a human heartbeat. An ECG displays only electrical activity of the heart, but cannot measure cardiac timing events associated with valves opening and closing. It's widely used by doctors to detect irregular heart rhythm, but it's not sufficient on its own to screen for heart health. While an echocardiograph can measure the cardiac timing events by displaying an ultrasonic image, it is a costly device used mainly in hospitals for detailed assessment or diagnosis of suspected or known heart disease. Now, through medical innovation, HeartForce has developed a new practical approach to accurate heart assessment: the HeartForce cardiograph. Similar to the way scientists use a seismograph to capture the force and timing of earthquakes, HeartForce's technology captures ultra-low frequency vibrations generated by the heart and carried through the chest to measure the force of contraction and the timing of the heart function. It is small, inexpensive compared to other diagnostics, and non-invasive, with the ability to capture 800 data points in a single heartbeat, about 10 times the amount of an echocardiogram and 4 times the amount of an ECG. These data measure what are known as systolic time intervals, or STIs, an accepted medical diagnostic. The HeartForce cardiograph uses 2 specific STIs to create a ratio. PEP is the pre-ejection period, the time from the start of the ventricular contraction until ejection of the blood, leaving the left ventricle to the aorta. It also measures the left ventricular ejection time, or the LVET. By dividing the PEP by the LVET interval, we get the STI ratio, which is then reduced to a simple number on a scale. This would show a healthy heart, or an unhealthy heart. As the STI ratio increases, the heart is becoming less healthy because it takes longer to react and then contract. Using the STI ratio and other proprietary algorithms applied to the movement of the heart, the HeartForce cardiograph can generate precise measurement for heart health, physical fitness, and stress, and can be used as a data platform for more accurate real-time heart assessment. The HeartForce cardiograph is a practical new means to monitor and assess the heart and measure performance for better management of personal wellness and fitness. A new measure of heart health.